we're going to walk through a learning activity, and you can find the link if you want to review this on your own in the notes that are entitled Unit 2, Day 1, What is a Radian? So our goal in this activity is to learn about another way to measure angles. And in the past, you've primarily used degrees, and today we're going to learn about another way to measure angles called radians. So we know that when measuring in degrees, there are 360 degrees in one circle or in one full revolution. And that's really an arbitrary measure where someone decided years and years ago that there should be 360 degrees in one revolution. So a degree is simply 1/360th of a revolution or of a circle. And a second unit of measure for angles is called a radian. And a radian actually has something to do with the physical properties of a circle. And we're going to explore that, and we'll explore that now.
Two methods are typically used to measure angles. They involve degrees and radians.
So here we see degrees on the left with the protractor showing that they're 180 degrees in half a circle. And then this activity is going to explain the meaning of a radian.
The Babylonians chose to divide a circle into 360 sections. Select Next to learn why they picked the number 360. One theory was that 360 was chosen because the Babylonians believed it took 360 days for the sun to pass around the Earth. Whatever the reason it was selected, the number 360 carries no special significance when working with circles or triangles.
So as we can see, 360 is arbitrary, but a radian is not. And I'm going to let the video or the activity explain a radian, then I'll explain it a little bit more myself.
Radian measure is based not on a number chosen by man, but on the basic components of a circle. A radian is the measure of the central angle subtended by an arc equal in length to the radius of a circle.
So let me explain this a little further. So if you think about measuring the radius of the circle, and let's say we took a string and made it this length of one radius, and then we took that string and we brought it around the circumference of the circle. That's what's shown in red here. A radian is defined to be the angle or the amount of rotation which is needed such that the arc that is intercepted, or the arc length here, is equal to the radius. So a radian really has to do with characteristics of a circle, not some arbitrary number like 360 for defining a degree.
A central angle has its vertex located at the center of a circle. This is subtended by an arc equal to the length of the radius. The green sector represents an angular measure of 1 radian.
So if we look at this diagram, theta here is the amount of rotation required such that the arc length that's intercepted is equal in length to the radius. And this angle theta is defined as 1 radian.
Let's view an illustration of 2 radians.
So here we can see what 2 radians mean. 2 radians mean rotate around from the horizontal, the amount of rotation such that the arc length that's intercepted is equal to 2 radii, right? So this angle here that I'm highlighting is 2 radians because the arc length that's intercepted is 2 radius, is equal to 2 times the radius. Now let's think a little bit before we go to the next slide as to how many radians there are in a full circle. So in this diagram, we can see 2 radians, right? So if we put another radius around, we'd be at 3 radians and another radius before, etc. So is there a way for us to figure out how many radians there are in a circle? So if we think about geometry, we know that the circumference of a circle is equal to 2 pi times the radius, right? So each one of these pieces is equal to the radius. So if we go all the way around, we go 2 pi times the radius. So we would have 2 pi times this number, or this length piece. And 2 pi as a decimal is 2 times about 3.14, which is 6.28. So it would take 6.28 pieces of length, 1 radius, which is I'm showing here, to get all the way around the circle, which means that there are 2 pi radians in 1 full revolution. And that's going to be important when we're thinking about what is a radian and how we convert from degrees to radians, because we can say that there are 2 pi radians in 1 revolution, as there are 360 degrees in 1 revolution. Now let's see what the learning activity shows us for this conversion.
How many radians are equal to 1 complete revolution? The circumference of a circle is equal to 2 pi times the radius. Remember, pi is the ratio of the circumference of a circle to its diameter. As you know, there are 360 degrees in a circle. Therefore, 1 revolution equals 2 pi radians, or 360 degrees. 1/2 revolution equals pi radians, or 180 degrees. And 1/4 revolution equals 1/2 pi radians, or 90 degrees. Therefore, there are 2 pi radians in a circle.
And this 2 pi radians at 360 degrees is what we're going to want to remember.
Demonstrate your knowledge of radians by answering the following 3 multiple choice questions.
So this problem says how many radians are depicted. So we can see here we're going halfway around the circle. We know if we went all the way around the circle, that would be 2 pi radians. So halfway around the circle would be half of 2 pi, or pi radians. So I'm going to select pi. 180 means that's how many degrees there are represented, not how many radians. Okay, let's try the next problem. So now it's saying how many radians are depicted. So how far, we want to say how far around the circle are we going? We're going 1/4 of the way around the circle. So we're going 1/4 of 2 pi radians. 2 pi radians would be all the way around. So 1/4 times 2 pi will be 2 pi over 4, which will be pi over 2 radians. 90 is the number of degrees, right? We're talking about radians. So I'll submit that. And then the last question is showing how many radians are depicted. And remember, every time we go around this portion of the circumference equal to 1 radius, we have rotated 1 radian. So up to here would be 1 radian, this would be 2 radian, this would be 3 radians, and this would be 4 radians. So since the piece on the circumference that we're going around has a length of 4 times the radius, the angle that we're going across here, the amount of rotation, is going to be 4 radians. Not, these other answers don't make sense. 4 radians.
Now that you know there are 360 degrees and 2 pi radians in a revolution, you will be better prepared to work with angles when designing and fabricating products. You have completed this learning activity. What is a radian?
Okay, so we're going to summarize this in the next video where we talk about the actual notes.